Missing number in an array. Another asked question in interview. Given an array, in this case, find the missing number. 1, 2, 3, 5, and 4 is missing. 1, 2, 3, 7. Here, no, 9 is missing. Easily enough, if it is sorted, which is incorrect in this example, but I wouldn't assume that's always the case. Anyway, I already wrote some boilerplate to parse. Well, I need to see that it is possible to set some default code. How does it work even? Okay. Okay, let's do it now, whatever. I hope it brings me back to... No, this is not what I wanted to see. I want to go back to... Okay, and it's still there. Okay. What is the simplest way? Of course, the simplest way is sort the array and from the beginning to the end, well, it is enough. It only starts from 1, so this is the count. Well, for element in SL, if L is if L is different from Cn, return L, else nothing actually. No, else, well, else increments this one, obviously. If nothing is found, I guess I should return -1. Well, that seems easy enough. Let's take the five and 10. Well, actually, really. Oh, that's interesting. Why would they return 5 and 10 instead of 9 and 4? There is something that I don't understand actually. Well, how do we... Is there a way to debug here? Well, let's do this. Let's see if actually... Oh, obviously. Well, in this case, it's well, it's ridiculous. It's not L that has to return but Cn. It's actually the counter, not the element that has not been found should return the element that has not been found, not the element that is. Well, that was kind of stupid. Okay, let's remove this. Okay, and that is the correct. Submit, and let's see if it accept it, or it says input 2 1. Okay. Right. And would be okay, so 2 and 1, and the 2 should be returned. Well, actually, in this case, always returns n. Okay, that's correct answer. Okay. Easy enough. Should I check the editorial? Because, well, of course, I guess there is a more efficient way, because now because of sorting, the time complexity is n log n. But as always in this problem, there is a more, not less obvious solution, which is has a better time complexity. So. Well, you're not going to be surprised that there is actually a smarter solution. Now that involves a formula which says that if you have the sum of all numbers from 1 plus 2 plus 3, 4, 5 plus n, the result is actually n multiplied plus n minus 1 divided by 2. If for n equal 10, that is, it would be 45, for instance. We can use this fact to create an algorithm. You know, this is a stuff I have seen plenty of times, and I always ended up forgetting it. So let's get find missing number 2 using this fact. Now, after this sum, of course, I will scan the array to check the whether it is missing. It is the value that is actually missing. So let's see, we don't need to sort. We need to have an expected result n multiplied plus n minus 1 divided by 2. This is well, now that I think wouldn't be easier to sum up, to just sum all the arrays and it and find the difference. Well, I would make it would be linear for sure, actually. So the result seems to me n is equal sum L minus, no, actually er minus L is just 2 rows. Well, even 1 if I brought the first line into the second. Well, Okay, whatever. We don't need to define another variable. 2 lines, which can be reduced to 1 line. Let's run my code. Well, something is not working. Don't think so. Well, what is the difference? Because if I have n in this case is 10. For 9, why is 2? Then is 45 minus, unless this is not the correct number. Okay, let's do it for this. For 5, 1 plus 2 plus 3 plus 4 plus 5 is equal to 9, 12, 15. Well, 5 multiplied by 4 divided by 2 is 10. Well, actually it would be 6 for, well, actually it's true. The formula was incorrect. It's n plus 1. I don't remember. I did copy it wrong. So now let's see if still the result was kind of weird. Okay, it must be converted to an int. Let's submit. And it still is correct. Now, what I'm kind of weirded out is that I'm not sure if I need to do the sum. Actually, anything else, I don't see doing a sequence of several differences, or I don't see looping through the array manually and executing a difference on every element. I don't see it as a better solution, so I think I will stick to it. Well, actually, there is even a third method. Actually, there is a third method to find this. The solution of this is actually using the property of the XOR, of the XOR operator. We know that just for a simple case, let's see that we have this number, the total sum of all numbers of all the range from 1 to n, and the one that are missing. This is the list L that is actually being passed as a parameter. Now, if you do OR operations, that we can use the associative property, we write it that way. When if you XOR a number with each other, it becomes 0, and 0 is the identity operator of XOR, and in the end it gets simplified to this. So this is what we do, what we can try to do it. We can actually write a number. Now, for instance, all XOR, well, I don't, we could reduce it. I don't know if it's worth doing it, but okay, anyway, let's do. I don't know if it's a good idea. Well, let me check if I need. I don't remember if it is a reduce, but okay, let me. I don't remember if reducing is a part of this. I think so. Let me check documentation of reduce. The first is the lambda and the second is the list. So okay, this is what the tutorial that I've been following. Lambda x epsilon x or epsilon L no wait, let's say range 1 n plus 1 and XOR is the same, but then I apply it with to L. Well, actually the result should be just L XOR XORed with all XOR, and I implemented the same idea, which is I XOR this one, which is all the number in the range between 1 and n, and the number in the list. Now let's see if it actually works. Reduce is not defined, okay, because reduce need to is in func tools, if I remember right. I wonder if this is correct. Let me just verify if this is correct. Yeah, it should be this this one. I wonder if that's actually import me func tools. 492 is that is a status, so let's submit it. Okay, but it doesn't seem extremely quick. So let me go back and see if I got it right. Yeah. Well, actually that's is what the algorithm suggests. XOR all the array elements, so that the result of XOR x1, XOR all numbers from 1 to n, XOR x2, and XOR of x1 and x2 gives the missing number. Well, actually, how was the solution in Python? Well, it's pretty much the same what I did, without just using the for loop instead of the reducing. I don't know if the reduce creates an overhead, but in the end, the idea is it's pretty much the same. Well, you know that in Python calling the function creates overhead, so let's do it again. No, well, I wouldn't. You know what? I don't feel like it. If you want it, you just whatever. I just copy and paste this one, but it's not worth. It's not worth it. Oh, well, that's in my idea. We know that in Python a function call is let's say atrociously expensive. Well, I'm not going there. Well, I'm not. I do believe in this solution is probably going to be quicker, but I don't feel like writing. I already did 3 solutions on this, and I want to, and then move on to the next problem.